So now let us see how we can solve this problem using data frames and Spark SQL. When we use Core API, we actually got the data as RDD. We applied a filter, map, reduce by key, sort by key, and then convert the data into Scala collection to get first three records. And again, to save it back to HDFS in JSON format, that array was converted into RDD, and that RDD is converted to data frame so that we can use SQL context .write.json to save as JSON. It's a bit tedious process. If we actually use Spark SQL, it is pretty straightforward. And we'll start with this Spark Shell command to launch the session. And as we have read the data earlier as part of the first problem statement, as well as this one, while processing data with the Core API, we will use the same thing here to launch the session and also to read the crime data into RDD and filter out the header. Okay, so first let me launch the session. I'm copy pasting this command to launch the session. Accidentally I copied the comment strings also. That's why it actually complained to begin with, but it is launching the session. Let launch and then we will take it from there. So the session is launched, and ignore this error because I accidentally copy pasted the comment also. I'm running 1 minute. Okay, I just cleared the screen by hitting Ctrl L. Now, after launching the session, let me read the data and also filter out the header. Okay, as we get the strings, now we have to extract only the information we need to convert into a data frame. First, we'll convert into a data frame before applying filter or any other logic. And the way we can do is, as part of the problem statement, they have already given this split logic. We will use this to split the data. So here I can say crime data without header dot map. Let me add it to the new line. Implies. Here I am creating a variable val r equal to rec dot that split logic and comma -1. I forgot to copy this comma -1. And now R is nothing but array which have all the fields. And from this, I am only interested in two fields. One is the location description, which is 8th field, which can be accessed by R of 7. And the other one is primary type, which is nothing but 6th field, which can be accessed using R of 5. We don't need anything else. Even though there are a number of fields and we can extract all those things, it is not good idea to extract at this time because it will take time for you to give the names and all. So we'll limit only these two, and then say 2ds, and the first field name is location description, and the second field name is, let's say, crime type. Okay, now you have a data frame, and let us give the name to it. Val crime data without header. Df is the data frame name. So now let me copy paste this code. Okay, there is some syntax issues. Let me figure out what it is. So let me copy from here to here. Okay, and then rec r equal to rec dot split. Yeah, it should work. Let us see. Yeah, previously I don't know why it failed. Now it worked. And we can actually review the data by saying copy, paste. Okay, previously it failed because there is no double quote here. And now I have added it when I copy pasted from the problem statement. And the reason why we are using this is there are records where data is enclosed in double quotes and a field might have comma in its value. And if I do not use regular expression, then that field will be broken into multiple values and it can cause data issues. For that reason, we have to use regular expression. And the logic is already given for you as part of the problem statement, because it is unfair for you to think about the regular expression and come up with the logic at the time of examination. It is not possible if these kinds of questions are given as part of the certification to complete in a couple of hours. Okay, for that reason, if there is any complex logic like this, they will give as part of the problem statement itself. That being said, let me run show command to see the data or to preview the data. You can see the location description and you can see the crime type. Now I can register it as a temp table and then I can run a query against it. And the way I can do it is crime data without header df dot register temp table crime data. Okay, once you do that, now you can start running the queries against the table. And the way you can do it is using SQL context dot SQL. Before that, let us give or let us set this setconf. Let us set this argument called spark dot SQL dot shuffle dot partitions to lesser number. Otherwise, it might run 200 tasks if the shuffling is involved as part of our query. To overcome that, I am giving spark.sql.shuffle.partitions as 4 because we are only interested in residence data. The volume will be very low. Hence, using 1 or 2 or 3 or 4 is good enough. And now I am trying to run the query saying select star from crime data and dot show. This will show whether my query is working or not. First, it is better to run this query to make sure that queries are working on the table. You can see queries are working on the table. Now I can say select location. Location description is not required. Crime type, comma, count of 1. Okay. From crime data. Where location description equal to residence. We are only interested in residence. And when it comes to queries, it's better to put the strings in the where condition in single quote because our actual query is in double quotes. Okay, so now I can add one more line to this and say group by crime type, order by, let's say, crime count. The field name is crime count, that we have to fetch it from the data itself. Okay, they haven't mentioned the field names, so you can give whatever you want. In this case, I'm just saying crime type and crime underscore count. Okay, So crime type and crime count are the field names, and I want to sort the data by crime count in descending order. And also we just need first three records after sorting the data. We don't need everything else. Okay, so there are multiple ways to do that. One of the better way of doing it is by using over partition notation, um, uh, or another way for the simple scenario is just by saying select star from okay q, and then limit 3. So we'll only get first three records. And first let us run this query to confirm that it works as expected. Then we can save the data into HDFS. There is one issue with the query. Yeah, I think it looks good. I can run this. Let me run these two code snippets. Okay, there was some error. Order by crime underscore count DESC. Okay, I know where the problem is. There is no space here, because of which crime underscore count and from will be concatenated side by side. Now it should work. Now we got the data we were expecting. We got all the top three crime types within residence region, and these are the crime counts for those three, and they are in descending order. Now I can actually say, instead of show, this is a data frame. Hence I can say uh, either save and give the path. The path is whatever is given in the problem statement. And I have to replace this. As the output type is mentioned as JSON, I can say comma JSON. Also, the same thing can be saved by saying whatever data frame that is created because of this command dot write dot JSON, and we just have to give the path. With save, it takes two arguments. With write dot JSON, it will take only one argument, which is path, and we don't need to compress the data or anything. So we can just give like this. But as I have ran uh, similar logic earlier using core API, and the files are created in this. First, let me delete these files from the file system. So I'm connecting to the lab with another session, and then I'll be running Hadoop fs-rm-R, paste the path, and the data will be deleted. Let me see, Hadoop fs-ls, paste. I think it is already deleted. That's fine. So let me now run this. Paste here and hit enter. Now, as there are 12 threads, data might be copied using 12 threads. So to reduce that, you can actually say shuffle partitions to be 1, or there might be other ways also. I think you can also use coalesce on the data frame to reduce the number of fields to 1, number of files to 1. So let me try that. I'm not sure whether coalesce is there on top of data frame or not, but let us see. Because for 3 records, I don't want to have 12 files to be created unnecessarily. Okay, so I'm deleting the files here. And then I want to use coalesce to copy the data. Yeah, coalesce is working. So now you will see only 1 file as output. Otherwise, there will be 12 files, which is waste of the HDFS. HDFS is designed for fewer files, fewer larger files. Here, creating 12 files for 3 records is not good for HDFS. Hence, using coalesce to reduce the number of files is a good idea. We will see whether it actually created 1 file or 12 files after the script is executed. I'm just running ls on that solution 03 to see how many files are created. Okay, this is only directory. Let me give ls on the directory also, so that we can see the number of files created. You can see there is only 1 file. We can also do cat on this, hadoop fs-cat. We can see the data here. And also, as I have been saying, it's better to review the output using a programmatical approach, that you can actually do sc.text file and then give the path, which is nothing but this one. Paste and then dot collect dot for each println. We need to make sure that data is saved the way we want. So this is how you can come up with the solution for the same problem statement, which we have provided solution using Core API earlier with Spark SQL as demonstrated in this case. And you can see it is a bit straightforward using SQL compared to Core API, because with Core API we have to convert RDD to array, and from array we have to get the first 3 elements, and then we have to reconvert into RDD, and then we have to convert to data frame, and on data frame we have to use JSON, write.json or save to save into HDFS. And here it is very straightforward. Just create data frame, run the query, and save the output, which is in the form of data frame, to HDFS.